That was a good intro. Well, Martin pretty well covered my opening slide, and I was a NASA employee for 38 years in Houston. And I started out in the Landing Recovery Division in 1964 and was there for 7 years, and all that time I was working on Apollo. And the type of things I was doing, I was a project engineer for boilerplates, and one of those is sitting right over there. We did water testing for the boilerplate. And in the Landing Recovery Division, we were responsible for everything that happened on the water after a splashdown. And that regards to, getting the crew safely back on the ship and having the ship recover it and everything that happens. And so I started out with boilerplate 25 for about the first year, and we did water tests on that. Then I was switched over to 1101, and that was good for another couple of years. And then they moved me over on the spacecraft that we used to qualify the recovery systems. My next big job was in 1968, just before Apollo 7. They decided that we needed a emergency access capability if we had a launch abort, pad abort or near pad abort. And in that case, in case you drifted back over land or you landed in the surf or on the beach or in the swamp around the pad, well, you might encounter a hard landing, and it would probably deform the structure such that you could have a jammed hatch. And so we called our little effort Jammed Hatch Kit. And like most everybody in the Landing Recovery Division, while the missions were going on, we deployed as recovery engineers. And I went on several. I was on the first unmanned Apollo, and that was in February of 1966. And then I became the emergency access engineer for launch site recovery, and I was down for 8 missions on that. And then also after the mission, we had a responsibility to safe the command module for transportation, and that involved removing the residual propellants, the RCS propellants, as well as safing the pyros. Just to refresh you a little bit, we used 2 launch vehicles in the Apollo program, the Saturn 1B, which is used for Apollo 7, and then after the Apollo program, we used it for all the Skylab manned missions, as well as the Apollo-Soyuz test project. And all the other manned missions in Apollo 8 through 17, we used the Saturn V. The Saturn V launched from 39A, and the Saturn 1B, at least on Apollo 7, launched from the Air Force Station site on Pad 34. Just to refresh your memory, a little memory about Apollo, the conical part on top of the right-hand side of the figure was the command module, and that's what we have over there. That's a boilerplate shell, but this was the real configuration. Under that, you have the service module, and to the left of that, set on top of the command module, and that was the launch escape system with the boost protective cover underneath and the launch escape motors on top of that. So I'd like to go in a little more detail about command module boilerplate 1101 right over there if you've had a chance to see it. These were non-flight Apollo command modules, essentially a shell, and these 2 are the 1100 series boilerplates were made out of 5056 aluminum, which is for marine applications, since we were going to have it in and out of the water a lot. And we built 2 of those, 1101 and then 1102, and I'll talk about 1102 in a little bit. And that was designed in-house by the Landing Recovery Division Design Section, and it was fabricated at Kelly Air Force Base by the Aero Material Command. And the reason they were picked, because they had the capability to form the large sections of aluminum plate. And it ultimately was delivered in early 1965, and if you notice on the picture You can tell the top part's a little different from 1101A over there. And what it was delivered in Apollo Block 1 configuration, which is the Earth orbital configuration. And at first, first thing we did was do development tests on the uprighting system, and I'll talk about that later, and the flotation collar, which you've all probably heard of. And the picture on the left is right after we took delivery, and we're doing the initial weight and center of gravity, which is like the ballasting and getting the point in the spacecraft that is the center of gravity. And that's me on the right, and I was all of 22 years old, so I was having a good time. And after we finished with the Block 1 development test in '65, we modified it to Block 2, which is the lunar configuration. Like I said, we did the static testing in the tank. We got a water tank there at the facility, as well as we went out in the Gulf of Mexico for development testing. And a lot of developing testing, you do failure. We have 3 bags on the upper deck, and if one of those failed, then we have to be able to upright it. And I want to mention that you might have heard of inverted and uprighting or upright, as well as that's called stable 2 and stable 1. So after we finished all the work with it in 1966, it was in storage till about 1974, and then 75, the Disabled Veterans Post here at Wheat Ridge asked for a Apollo artifact for display, and the Smithsonian obliged by loaning them 1101. And after that, well, when they closed, like Martin mentioned, in 1975 it was transferred, I'm sorry, in 2001 it was transferred to Wings. And on the left is a picture of our Block 1 sea test. And this is, we would go off Galveston and put it in the water and do upritings with it. At that time, we had a hardwire system, so myself and a test conductor were in the raft. And we had safety swimmers, so. So what we have now is the 1101A configuration. It's Block 2. Block 1 was Earth orbit, Block 2 was lunar mission. And the big difference is the upper deck area, the flat portion, and which goes into the tunnel portion, and all that changed between Block 1 and Block 2. And this is what it looked like when I first came out to Wings in 2006. And of course, I'm a magnet, or aviation museums are a magnet for me, so I came out here and I was surprised to see they had a boilerplate. But you can't see it there, but they had a picture of another boilerplate, and I didn't really realize that was my boilerplate, my old boilerplate. And when I went back home and kind of looked into it, I realized that was the one, and when I looked at it further, I can tell that it was mine, because the hardwire box on the right there was our Block 1 control system for the uprighting test, and the wireless antenna, there were 2 of those, were a Block 2 control system for our uprighting tests. This is when Martin and I took a look at it out in front, when it was still out front, and we kind of wanted to see what it looked like on the inside. And like I said, the boilerplates are just a shell, and you can outfit the inside however you want to. In this case, we were more interested in making the thing just right ballast-wise. So since it's made out of aluminum, we end up with a lot of lead ballast on the poles as well as on the floor. And the little wiring is left is from our uprighting test. So our testing involved working with the flotation collar. In fact, this is the first time that we had it out in open water in the Gulf of Mexico. And if you can look on the right-hand side, on the horizon, that's Galveston. So we would go out about 5 or 6 miles off Galveston and put it in the water and And these are the block 1. And they were manufactured, you've probably seen the flotation collar used in the recoveries. And this one on the left, you have the NASA swimmers swimming the collar package out to the boilerplate, and on the right they finished and standing, and they kind of used it. The swimmers kind of used it as a work platform once they've got it inflated. Now we go on to the uprighting system, and the uprighting system was 3 bags, 2 side bags and 1 center bag, and the side bags are 43 inches in diameter and the center bag was 34 inches. And one of the things we found out in our uprighting test, if we have 3 bags of the same size, if you lose one of the side bags, it will not upright, it'll just kind of roll. So they reduce the size of the center bag, so with a side bag failure, you can come upright. And this is still the block 1 test we did out in the Gulf. That's me in the white hat in the raft. And all these were unmanned, of course. That's when we were controlling it with the hard wire. And this is in 1966. We had already modified it to the Block 2 configuration, and we're out on the NASA motor vessel retriever, which is an old flat bottom LCU we got from the Army and modified for our purposes for testing in the Gulf. And here we're putting the 1101A over the side. We're going to do failure mode uprighting tests. I was always impressed by the crane operators that would put it over the side gently, and then you'll see that the boom crane would flip it. That was always impressive to me, that they did it without touching. And you see the yellow tape around the hatch area, and that was our duct tape of the 1960s. We've released it, and it's floating on its own, and you can see what it does just in relatively calm conditions. It rolls and pitches, and you can imagine the crew going inverted and hanging in their straps on their couches. So it's and the Block 2, we were wireless, so we didn't have to be out there in the raft, and we were operating it from the motor vessel retriever. You see one of the side bags is coming up. On average, an uprighting will take about 6 minutes. And if you have one failure, either a bag failure or one of the 2 DC motor air compressors, it'll take anywhere from 11 to 12 minutes. And we never did have that case. On one of the missions, I think Apollo 7, one of the bags was partially inflated, so it took a little longer, about 8 minutes. The bags were made by Goodyear, and they were polyurethane impregnated Dacron. You can see it came upright, and you can see it pretty well is pitching and rolling still. And so it's just as soon as the frogmen or the parajumpers could get the collar on, the better for the crew, because it made a real stable platform. And here we're just retrieving it on the retriever. That hook he just captured the recovery loop with is a pretty neat invention out of the Mercury program, and we were still using it during Apollo. Just to transfer the line that enables them to hook the hook directly up to it without having somebody up there doing it manually. The two guys on the ship are just holding it off, and like I said, I was always impressed by our handling crew, because you can see it doesn't have many dings on it, but in open water like that, it's constantly moving, and you could easily hit the side of the ship. And this was just the start of another test. We'll go to the next slide. So we had pretty good success post-landing wise with the two systems that we worked using 1101, and 5 upritings after splashdown on 11 missions. So it was just a matter of luck depending on if you went inverted after a mission. And the astronauts always claimed it was the parachutes before they were released after they hit the water would pull it over, but sometimes it was just the wave action. Then we had one uprighting on Skylab 4 and another uprighting on Apollo-Soyuz test project. And all the missions on Apollo, Skylab, and ASTP the flotation collar was successfully deployed and used from the aircraft carrier. So all those missions were covered by the aircraft carrier. I mentioned the sister boilerplate of 1101, and that was 1102. It was also a shell, but since we were going to use it for crew egress training, we had the windows put in as well as the hatch, and then the outfit, the crew compartment was outfitted with simulated hardware. So in an egress training with astronauts, that is, we went through procedures to allow them to get familiar with how to get out and get into their raft and be recovered. All that was installed, and this is the final mission that we, on ASTP, that we trained the crew, and that's Deke Slayton in the hatch, and Tom Stafford on the right, and Vance Brand with his back to us. And 1101 is here. 1102 is in the Udvar Hazy Center up at Dulles Airport, Air and Space Museum. And with it, which is interesting to me, is it has the original Apollo 11 uprighting bags as well as the flotation collar. So, and if you're at the museum and you're facing the nose of the orbiter, it's to the left. So don't miss it if you're ever there. Next thing I'll talk about is the command module launch site emergency access, in other words, the jammed hatch kit. For all the missions, there was a possibility of an abort right off the pad or near pad, and so we had a team in place at the launch site to cover this eventuality. We had a little help from the Air Force. They supplied the helicopters, and we had firefighters from the local Patrick Air Force Base. We had a recovery engineer, and of course our main job was to recover the astronauts safely and the command module. And before each mission, we would meet 1 week before each launch and go through each scenario that we might be involved with, whether it's in the surf or on the beach or the land or the water around the pad area. So if we have any of those situations, we could have a hard landing and deform the structure and jam the hatches, hence jammed hatch kit. And also, if we had a hard landing, we could possibly rupture one of the RCS propellant tanks and have a fire situation. So that's why we had firefighters. And the whole strategy, if the side hatch was jammed, we would go cut through the tunnel, which is an aluminum honeycomb, and get into the command module. At the same time, the firefighters would break out one of the side windows, and we had a portable ventilator that we used to get fresh air into the command module. And it was assumed we had an incapacitated astronaut crew. And so we had to be really careful what we did and able to get them out safely. So for each mission, I was stationed on the pad access road for 39B, and that's probably the same distance as the VAB, 3.5 miles, something like that. So it's pretty good front seat row for the launch. That was our crew we had for Apollo 9 in March of 1969. I'm far left, and all the other guys are the real workers there. That's the Air Force. We had pilots, PJs, and firefighters from Patrick. Well, I didn't mention, that's one of the big helicopters we had. We had 2 of those and a smaller command helicopter. These are 53Cs, and they're capable of lifting the command module. So, and this is me. I'm on station for the launch, and this is Apollo 13 on April 11th. You see the jammed hatch kit. So it's 2 parts, and I have my breathing apparatus and my ventilator there. So we're ready to be picked up in case we're needed. I only flew on the helicopter once for launch, and that was Apollo 10. And we would have a L-4 hour team briefing, and we went over the weather situation. And only on Apollo 10 did we have what we say is offshore winds that would predict the command module coming back over the beach line, and maybe have a land landing. So we were ready for that, and I flew on one of the backup 53Cs. And if you look in the background, the tall structure, the gantry, that's Apollo 13 sitting on the pad. And that's my last slide, and I wanted to mention that 50 years ago tomorrow morning, that was where I was.